Sometimes we have a surface with a given contour, and we need to find the equation of the tangent to that contour at a given point. So there's a 5-step method of doing this. The first step is to find the gradient function. In other words, the partial derivatives of the function in the x and y directions. So you can write that as a vector, or you don't have to. You can just keep the partial derivatives. Then substitute the coordinates of x and y into those, so you end up with a numerical value for the direction of the tangent. And that involves switching the positions of the x and the y, with the x being negative. Another way of saying that is you can write the gradient, or the slope, as negative fx over fy, where fx is the partial derivative with respect to x, and fy is the partial derivative with respect to y. Your final step is simply to use the standard equation of a line using the gradient you just found and the coordinates of your given point. So that's how you would approach a question that involved finding the tangent to a contour. So if we look at this example, here we're given the equation of a surface, and we're given a point, and we're given a contour that passes through that point, and we're asked for the equation of the tangent to the contour. So the first thing we'd need to do would be to find the partial derivatives. So partial derivative with respect to x, we assume that every instance of y is a constant. So the 3x cubed becomes 9x squared. The x squared becomes 2x, and the y squared is unchanged. It's just a constant. The 2xy becomes 2y because the y is a constant. And the 4y squared and 3 is just 0. So you've got plus 0 minus 0 because there's no x. All right, so that's our fx. We can do the same for fy, which is the partial derivative of f with respect to y. So this time we'll assume that the x's are zeros, so the 3x cubed, different derivative is 0. The x squared, y squared becomes x squared times 2y, so it's negative 2x squared y, plus 2x, because the x is considered a constant, plus 8y minus 0. Okay, so these zeros are because we're treating this time the x as constant. So now we have fx and fy. We have our gradient function, which is simply fx, fy. So fx all multiplied by I and fy multiplied by j. So we can write this like this. Nabla f, and you've got your I and j, so you'd have 9x squared minus 2x y squared plus 2y. You have minus 2x squared y plus 2x plus 8y. So that's your vector. So this is your I component, and that's your j component. The next step is we substitute the values of x and y into x and y in our vector. So now we can substitute x equals 1 and y equals 1. So you've got 9 times 1 squared minus 2 times 1 squared plus 2 times 1 for x. For I, and for the j, you've got minus 2 times 1 squared plus 2 times 1 plus 8 times 1. And that will give you 9 and 8. So that's your gradient function. You now want the direction of the tangent, which is negative fy x. So your direction of your tangent will look like this. Negative 8, 9. And then you can write the equation of your line, or let's find the gradient m, which is negative fx over fy. So m for your tangent is negative fx over y. So that's negative 9. And we can now write our line as y minus y naught equals m times x minus x naught. So y minus y naught equals m times x minus x naught. And m is 9 over 8, so that's the value we just calculated. So that goes in there. You've got x naught and y naught. These are given in the question as 1 and 1. So we can now write that as y minus 1 equals minus 9 over 8 times x minus 1. And if you multiply throughout by 8 to get rid of the denominator, you'll have 8y minus 8 equals minus 9x plus 9. And you can rearrange that to 9x plus 8y minus 17 equals 0. And I think that should be your final answer. So that's the equation of the tangent to the contour of a surface at a given point.